Welcome to After Dark Online. Thanks for joining us as we continue to explore current topics through science, art, and conversation. My name is Sam, and I'm a program developer as part of the team that produces After Dark. And though this program is virtual, the Exploratorium is located on Pier 15 in San Francisco, on unceded territory traditionally belonging to the Ramaytush Ohlone people. As an institution, we recognize that we are guests on this land, and we honor the stewardship and that the Ohlone people have offered for the ecology we inhabit, both past and present. To talk about tonight's program, we are actually kicking off a month-long series for After Dark Online called Agree to a Degree, where these programs are going to be looking at choice, personal decision-making, collective decision-making, what influences our preferences, and how it contributes to the democratic political process. So tonight we're going to hear from two different researchers about uncertainty and how to better understand it. The first will explain election polls and what they tell us and what they don't tell us. Our second guest will be looking at the ways election forecasts have been visualized both in the past and in this current moment, and suggest ways to best read the data as a user. But first, we'll kick it off with a short animation about the astounding amount of decisions that one's faced with on any given day. Enjoy Mr. Würfel by Raphael Sommerhalder.
This is Mr. Würfel, and Mr. Würfel loves making decisions. Mr. Würfel starts his day at 4 o'clock every morning, because before he goes to work there is so much to do. Decision after decision. The blue, the grey, or the beige trousers? The red or the green tie? Parted on the left or on the right? Tea, coffee, raspberry, strawberry, or blackberry jam? Or rather the brown shoes. And the umbrella? But today will be different from all the others. Because on the way to work, Mr. Würfel will get into this unhappy situation. And this situation demands a very clear, quick decision. Mr. Würfel has only a little more than 1 second to make the decision of his life. 1,277 milliseconds. Once, when Mr. Würfel was a child, something terrible happened. It was Sunday afternoon. The young Mr. Würfel was playing in front of his parents' house. Suddenly, he saw this football in a neighbor's garden. Young Mr. Würfel just could not decide. And then, his gut spoke up. His gut said, "Get it." So little Mr. Würfel took the ball and kicked it into the air. And then everything happened very fast. And then the young Mr. Werfel was an orphan. Ever since then, Mr. Werfel hasn't listened to his guts. Ever since then, Mr. Werfel has made decisions with his head. Ever since then, decisions have become a passion for Mr. Werfel. For Mr. Werfel, there is no wait and see. For Mr. Werfel, there is only yes or no. For him, only the best choice is good enough. That's why Mr. Werfel checks everything very carefully. Every detail. Just like now. A step forwards or backwards? To the left? To the right? Or simply stand still? It took 3 years for Mr. Werfel to choose his new bicycle, and 4 months to decide if he should repaint his living room. And this morning, over an hour to get his bathwater to a perfect temperature. But now, in this very moment, a 523-kilogram concert piano is racing at 46 kilometers an hour straight towards Mr. Werfel. Actually, Mr. Werfel could have guessed that today would be different from all the other days. Because after he'd made all the usual morning decisions, and had just set out on his way to work, his guts cried out, full of desperation, "Don't go!" But for once, Mr. Werfel's head reacted promptly. And that's why Mr. Werfel is now in this unhappy situation. Good morning, Mr. Werfel. Please decide what you'd like to be in your next life. And take your time.
Welcome back. We hope you enjoyed that short. Now we're going to turn to a conversation between my colleague Kathleen McGuire and Dr. Courtney Kennedy, Director of Survey Research at the Pew Research Center. They're going to talk about election polls, how they're conducted, what we can learn from them, and how best to approach the data as a news consumer. Courtney serves as the Chief Survey Methodologist for the Center, providing guidance on all of its research and leading its methodology work. She has worked as a statistical consultant on the U.S. Census Bureau's decennial census and on multiple reports appearing in Newsweek. She achieved a doctorate from the University of Michigan and a master's degree from the University of Maryland, both in survey methodology. Courtney has served as Standards Chair and Conference Chair of the American Association for Public Opinion Research. I look forward to hearing this expertise. Take it away, Kathleen.
Thank you so much for joining us, Courtney. To get started, could you just tell us a little bit more about what the Pew Research Center does and also your role there?
Sure. Pew Research Center is a nonpartisan, non-advocacy research organization. We're based in Washington, D.C. DC's got a lot of, people know as think tanks that work on policy and whatnot. We're a little different. We like to think of ourselves as a fact tank. We like to do research that generates facts that we hope will make a contribution to the national dialogue, whether it's about American public opinion in other countries around the world, or just broader trends in society. And my job there is Director of Survey Research. What that means day to day is that I help design the surveys that we do at Pew Research Center, where we recruit people, logistically how we interview them and so forth.
Great. And today we're going to dig a little bit into election polling and help our audience understand some of the ways to better understand polls. But maybe to start out, could you tell us a little bit about why election polls are important, and looking historically, how have they influenced decision-making in past elections?
Sure. Well, I think they're important for reasons that might be a little different than you might guess. So undeniably, the public can have a voracious appetite with regard to election polls to know like who's going to win the election or who's ahead. And that's perfectly understandable. But frankly, that sort of horse race data is not really the strength of polling, especially if you've got a competitive race where someone can win by a razor thin margin. Polls, frankly, are not precise enough to get like a razor thin margin correct. But polls are really good for other purposes. So I'm thinking about what issues are motivating voters. How are voters reacting to the pandemic? How do voters feel about the candidates? What issues are really on their minds as they think about going to the polls? How do they feel about access to voting this year? So I think a lot of those more high level, policy issues and reactions to the candidates, polls are perfectly up to the challenge of giving us useful information about that. But they're not so good at telling us who's going to win, a close election months from now. And you had a second part to that question. Can you cue me in about what that was again?
Yeah, and sort of historically, are there examples of polls being influential in past elections in the public's decision making? Or I know last election, they were a little messy
Right.
as well.
So when I got this question before 2016, I really brushed it off. And I think a lot of my colleagues in the polling field did as well. And we did that, frankly, because there was never good or strong science suggesting that just the mere, presence of polls being done and talked about, that really had a meaningful impact on voters and on their behavior and their thoughts and on the election itself. We like to think of ourselves as just people who measure something and report what we found. We don't like to think of ourselves as people who actively affect the election. And prior to 2016, I think that was a pretty reasonable, place to, a reasonable way to think about it, with maybe a caveat for primaries. Because in primaries where you've got candidates who are less familiar to a lot of voters, polls can, I think, admittedly play a bigger role. If a poll comes out and a candidate in a primary did particularly well, I think that that can be a boost to a campaign in terms of maybe getting some more donors, maybe getting some more volunteers and that kind of thing. But in a general election prior to 2016, we didn't think that polls really played a role in themselves. But after 2016, I no longer brush that off. I take that very seriously. And in particular, if you think back, there were two things going on. There were a lot of polls, yes, but there were also a lot of these forecasts, and they were really probabilistic forecasts. And that's a fancy word that just means people put a percentage on the likelihood that the candidates were going to win. And a number of, at least two high profile forecasters said that Hillary Clinton had a 99% chance of winning. And that got picked up. And that was definitely a real prominent narrative in the campaign. And one thing that happened in 2016 was in several key metro areas, especially in the upper Midwest, turnout was a big factor. Turnout was lower than it had been during the Obama elections. And I don't think it's crazy to question whether that narrative played a role in some people staying home. And one thing that's happened since 2016 is there's researchers are trying to look at that, with data and testing as to whether that narrative can affect people. And there's some emerging experimental evidence that if people are told a candidate is extremely likely to win, some people, not all of course, but some people may be less likely to vote.
And so election polls are something that we see pretty frequently, but we might not fully think about their methodologies if we're not sort of ensconced in a career like yours or sort of a math background. And you already brought up these sort of horse race polls that maybe we don't reflect on. So could you talk a little bit about some of the different methodologies that are behind polls, as well as sort of how consistent are those methodologies if we're looking between different polling bodies?
Yeah, that's, I think, one of the most fascinating questions this year, because polling, a lot of people don't know this, but we're in a very transitional era. And by that, I mean how, Fox News and CNN do their polling differs from how CBS and Politico do their polling. And that differs again from how Pew Research Center and the Associated Press does their polling. So there's a lot of different methodologies. So in particular, we've got some polling organizations still doing live telephone. That actually, even at low response rates, works pretty well in an election year. We've got a lot of other organizations that have moved online. And online, you've got sort of two different buckets. You've got most online polls that you'll see are opt-in, which means they're done with convenience samples, frankly, of people who are internet users that could have been recruited from a pop-up ad or an email from some membership listserv that you might be on, but they're convenience samples. But then there's online pollsters who are actually still doing offline, scientific, probability-based recruitment. So for example, the way we do it at Pew Research Center is we take the Postal Service, the master list of all addresses in the US, draw a random national sample, we contact people through the mail and recruit them to our online panel. So you have all those methodologies. We still have other pollsters doing robo-polling, sort of like the automated polling to a lot of landline phones. So there's quite a mix of methodologies. And you're right, for the average person, that's all sort of behind the curtain, because news outlets don't tend to make a big deal about those details, even though to me they're very interesting, of course. So to the second part of your question, there's some research about, do different approaches work better than others? And I would say on the whole, the differences maybe are not as dramatic as you might think. In 2016, there were not major differences in accuracy by those different types. Other researchers have looked at several of the recent elections, and if anything, they found that live phone polling still performs the best in terms of election work. But there's other good methodologies out there. Obviously, our approach where we interview online, but we still do a random national sample works pretty well in addition.
And could you talk a little bit, you have this fantastic blog post that we'll point people to on the Pew Research Center's website that is sort of about what to look out for when you look at a poll or what's going on sort of behind the numbers. Could you talk a little bit about weighting?
Sure. So weighting is a really critical step in polling. It's something that happens after the interview. After the interviewing's over, the pollster has their data set with all the responses that people gave. And one thing, I've been in the field for 20 years, and every public opinion survey I've done, it needs to be weighted. And the reason is some groups in our country are more likely to take surveys than others. It's just a fact, and it's pretty reliable. I mean, maybe it won't be shocking, but like older folks, Caucasians, college grads, people with more higher levels of formal education, for whatever reason, they're more likely to participate in a survey than younger folks, people with lower levels of formal education, and so on. And so to deal with that, what a pollster has to do is to make those groups representative, to basically adjust the survey data with this process called weighting to make it look like the portrait of the country that we have from the Census Bureau or some other high quality data source. So what we do is when we're done interviewing, we might have too many college graduates. We weight them down proportional to their share of the population. And then we'd weight up people with lower levels of formal education so that they're proportional to where they should be in the population. And we have to do this on a few different dimensions, gender, age, race, ethnicity, education, geography. As time goes by, that list gets, a little bit longer because we have to do more to compensate for low response rates.
And then, so as we're looking at polls and thinking about how we know that they can't be perfectly accurate and there is this level of uncertainty to them, how do you think people can sort of best use polls to inform their own decision making? And how much should they sort of weigh their knowledge that some of this is uncertain as they use it to inform themselves?
Sure. I think the best way to think about polls is it's going to give you, a high-level read of public opinion. But no, you really have to keep in mind that it's plus or minus, I would say, plus or minus around 5 points, maybe 6 points, regardless of what, that the press release might say plus or minus 2 or plus or minus 3 points. One thing that's just a truth about polling is that there's actually more error than those margins of error indicate, because those margins of error statements just talk about one source of error in polling, but there's actually 4. The margin of error only speaks to sampling error, which is the fact that we interviewed, say, 1,000 people instead of everybody in the state or everybody in the country. But the other error sources, we've got non-response, not everybody takes our surveys, mismeasurement, not everybody might understand the question exactly as we tried to ask it. And then there can be non-coverage. In some surveys, some people didn't have a chance of being sampled. So if you factor in all those error sources, you really want to think of polls as useful, but more like plus or minus 5 or 6. And so, I wouldn't encourage people to think that they should base their own opinions or their own actions off what they see in polls. Polls, I think, are useful because they give us a window into other, our colleagues, our American, brothers and sisters across the country. What are their experiences? What are their thoughts? Just to be better informed about what other people in the country or maybe around the world are going through.
Well, thank you so much, Courtney, for taking the time to chat with us today.
It was my pleasure. Thank you.
Well, thank you, Dr. Kennedy, for your time and insights. Up next, we're going to hear from Dr. Jessica Holman. Jessica is an associate professor at Northwestern with a joint appointment in computer science and journalism. The goal of her research is to develop user interface tools and methods to help more people make sense of complex information, and in particular to reason about uncertainty as they use data. She is the co-director of the Midwest Uncertainty Collective at Northwestern, which is a cross-institutional research lab working at the intersection of information, visualization, and uncertainty communication. Their mission is to combat misinterpretations and overconfidence in data by developing visual representations and human-in-the-loop tools that express uncertainty and align with how people actually think. Tonight, she presents a talk titled How to Communicate Uncertainty in Forecasts. In this talk, she compares visualizations of past election forecasts to election forecasts for the 2020 election cycle and shares how uncertainty can be successfully communicated. We are certain that you'll learn something from this talk by Dr. Holman. Enjoy.
Well, thanks so much for the introduction. I'm really excited to be here. My talk's going to be called How to Communicate Uncertainty in Forecasts. So the election forecast wars, as at least one journalism has called it, are upon us. The Economist just released their first ever statistical forecast of a US election, and 538 also did just this summer. And then a few other forecasts from political scientists are sort of trickling in, and you'll see those around the internet as well. So today I want to talk about how we communicate forecasts and about why our choices of how to communicate uncertainty in forecasts matter a lot. First, a little bit about me. My background is in visualization, which is kind of a subfield of computer science where we deal with interactive graphics. And I like thinking about how we can sort of optimize the ways that we show data, often to public audiences. But I have a particular interest in some of the statistical and even philosophical questions that come up in communicating about uncertain data. And my own background, as a result, is sort of threaded between both the humanities, reflecting my interest in how and why we communicate, but also computer science and statistics, reflecting that I like to think about solutions. And when it comes to determining the best solution for communicating uncertainty and model predictions, I think it's actually pretty tricky. So first off, why visualizations? Why do they matter? Well, I think as they're used to kind of inform the public and support decision-making, they play this important role in sort of helping people make decisions about what they should believe about the world around them. So we often care about something like some true state of the world, like what's the state of climate change, who's going to win the election, and data is a proxy for helping us answer such questions. So this is a visualization from 538's forecast this year showing predictions of vote share for both candidates, Biden and Trump. These are based on poll results, other types of assumptions, but this visualization is intended to capture sort of if the election happened today, what would we see in terms of popular vote? And we might look to this data then as the best possible estimate of the true vote share today. But of course, it's still just an estimate. And most of the data we visualize or see visualized in the press, in government, et cetera, is subject to uncertainty. That can be quantified uncertainty, things like sampling error. So when we're looking at data based on polls, we can't poll the entire population of US voters. So instead we have to take samples. There's some uncertainty from that. But we also have forms of unquantified uncertainty in various types of election forecasts that we see, or any types of model predictions. So for instance, is Nate Silver right about how much economic uncertainty he thinks COVID has contributed? Or is he right about, knowing how to weight prior election historical sort of forecast information or voting outcomes in making his prediction for today? And so if we think about sort of how visualizations can convey these kind of uncertainties to us, there's a variety of styles we can use here. I think we could say this visualization is doing an okay job just in that we are actually seeing these sort of confidence intervals here. So we know that while Biden has a 53% predicted vote share, there's some uncertainty around that. This could be better. I'll get into sort of how it could be better later, but at least we're seeing uncertainty. And I want to just point out before I jump into sort of ways to express uncertainty that election forecasting, I think, is a little bit unique in that it's a place where we see uncertainty often reported by default to public audiences, so readers of news publications like 538 or The Economist. But if you think about how you see visualizations many other times, when you're sort of casually surfing the web, looking at government reports, et cetera, it's often quite striking how comfortable we seem to be as a society with not presenting uncertainty at all. So we have extremes like the Congressional Budget Office, which will put out reports but not say anything about the uncertainty in their estimates, leaving us with visualizations that might imply that they're precise, even to the dollar when they're dealing with estimates in the trillions. And so this kind of thing we see a lot online. It's what I think is sort of a grand societal challenge. How do we get better at communicating uncertainty and as readers expecting uncertainty? But there's a lot of reasons, I think, why this happens, why communicating uncertainty is rare, and many of them deal with these real challenges in expressing it in effective ways. So a lot of people who are developing models, making estimates, analysts, et cetera, and releasing those to the public are often worried about things like, well, if I express uncertainty, it'll burden my readers. They might not understand it because they don't have a background in statistics. It's maybe not important to their task. And I think there's also this sort of perceived norm on the part of the people releasing estimates that, it's kind of not to their advantage to express uncertainty because nobody else does. So they think I'll look less certain or less sure of myself. And then there's also various reasons related to how it's hard to communicate uncertainty, or to calculate uncertainty. Also hard to convey it both visually or in other means. So a lot of times, I think authors won't feel comfortable that they know the best way to communicate it, and so by default they leave it off. So this is problematic, and part of the premise I want you to keep in mind when we talk about election forecasts today. So one of the reasons I think that people have trouble expressing uncertainty, model developers, et cetera, is that a lot of our visualization approaches that we typically think of for conveying uncertainty are just not so great. Like, they have issues that we can talk about. So I would argue that we lack sort of generalizable, widely sort of understandable visualizations for uncertainty. And when we look at sort of the current ways that we tend to visualize uncertainty that are not so great, I would say we could break them down into, on the one hand, things like confidence intervals, which we show using error bars or error envelopes like we see here, which are kind of summarizing aspects of uncertainty, or summarizing really properties of a probability distribution using things like graphical annotations. Box plots would also fall into this if you're familiar with those. On the other hand, another way that we often see used to convey uncertainty in estimates visually is using basically a mapping between something like a probability and some attribute of a mark in a visualization. So here I'm just showing the legend from an economist chart from this year, but they basically want to show by state the probability that one of the two candidates will get elected. And so the darker the color, the more probable, for instance, that one of these red states will elect Trump, or that the blue states will elect Biden. And so this is sort of the other category of technique we see. So I want to talk first about some of the issues with these sort of standard approaches, and then we'll talk about what's better. So in visualization research, at a high level, we have criteria that we use to talk about when sort of a visualization is useful or when it's good. And one of these criteria we call expressiveness. And expressiveness basically means that when we visualize data, the sort of spontaneous interpretation that the viewer or the reader comes to about what the data means should be correct. So we don't want to use visualizations that make us think things that aren't true about the data. And to give an example here, I have a bar chart that's showing us car models and the nationality of the maker. These are two categorical variables, and yet we're seeing them mapped as length of bars. And so this leads us to think things like, oh, Sweden is somehow more than Germany, or the car models from Sweden are somehow more than those from other countries, Germany, et cetera. And that's not true. That's not supported in the data. So this is what a violation to expressiveness looks like. And going back to our ways that we commonly visualize uncertainty, if we think of summary marks, things like confidence envelopes, confidence intervals expressed as error bars, they have issues in terms of the fact that what people think when they see them is often not correct about the data. So for instance, when people look at error bars, they often think they're seeing some sort of uniform probability range where any value along that error range is equally likely. The problem is that error bars are often used to communicate different types of uncertainty intervals. So a standard error interval, standard deviation interval, a confidence interval, and these have different definitions, and only sometimes is it true that it's a uniform probability range. But of course it looks that way, so we can't really blame people. It's a problem really with the expressiveness of the visualization. Another issue we see in a lot of people, I think the estimates are around 30% of lay populations, is this belief that the values that are on top of the bar when you see a bar chart with error bars are more likely values than those above the top of the bar. And again, it's sort of in a violation of expressiveness. It looks like that could be the case. People think of the bar as actually showing the data, but that's not true. It's not actually supported by the data. So these are some issues with these sort of use of summary marks like intervals. So we have to be careful when we interpret them. On the other hand, when we use these visual variables, when we map probability or confidence to things like how dark dots are, or the area of a shape, or how wide a shape is, or how blurry a mark looks, we can also run into problems, but this time with a criteria that we call effectiveness when we're doing visualization research. Effectiveness basically means that we want people to be able to look at the visualization and read the values accurately. So I want to, for instance, be able to look at a visualization and know, like quantitatively, how much more probable is a darker dot than a lighter dot. But that's difficult. So we know from visualization research that sort of studies how well, through graphical perception experiments, people can read data from different visual encodings, that some visual encodings are much better than others, or some visual variables, as we call them. So to give you a sense of this quickly, imagine I asked you, how much less blurry is B than A? That's a pretty hard question to answer. I could ask you how much darker is B than A here, still pretty difficult. How much bigger is B than A? Or how much longer is B than A? And what you should notice is that some of these, in particular this length, are really position encoding, because we're just comparing positions, given that the bars are on a common scale, is much easier to make. It's 1 out of 2 here. Whereas something like this, how much blurrier is B, how much bigger, or how much darker, is much harder. And so what we want to do in visualization is use the most effective encodings. But often the problem, going back to a chart like some of these here, is that we've already used position to show whatever other data variables we care about. So in a scatter plot, we have an X and a Y variable. By the time we get around to expressing uncertainty, we're left with these sort of harder to read encodings, things like opacity, things like area, things like color. And so we see this here in the full chart. I showed you the legend earlier. This is from the Economist forecast, where darker colors mean more probable. So there's not necessarily something wrong with this. It's not, illegal to do this. But the point is that it's hard to, at a glance, kind of make an estimate of how much more probable, say, is New York voting for Biden than Pennsylvania. So given a chart like this, we really have to rely on the legend up here carefully in order to make any quantitative estimates. So it's visually we're not doing the work visually. We're sort of really relying on the legend. I think a better way to use some of these encodings that look like uncertainty, like darker is more certain or less blurry is more certain, is to use them more for what we would call ordinal data or rank data, not necessarily precise quantitative information. So here, this is a chart from the Bank of England, which I think is nice in that, darker here means newer data, and newer data is potentially more relevant to whatever judgment we're making. This is about Brexit. But they're not trying to show precise quantitative information. We're basically plotting what month it is to how dark the bar is. So we're not trying to, the reader knows, that months are not quantitative. And so it's sort of a more appropriate use of darkness. But yeah, the challenge is that often the ways of expressing uncertainty that most look like uncertainty are the hardest to read. So I want to talk about techniques that we've found from research to be better, and that we'll see in some of this year's election forecasts. But before I do that, I want to point to another sort of deeper problem than just visualization with how we present uncertainty in forecasts or model estimates. And that's the nature of probability itself. What does it mean? So to quote a famous actuary and statistician, Bruno Di Finetti, probability does not exist, and that's the problem with it. And I think what he meant here is that probability is very hard to sort of objectively define. And even statisticians argue about how should we estimate probability? What does it really mean in the world? So, say I have some event that's going to occur with 30% probability, like Trump being elected. The problem with understanding probability is that we know that in the world, Trump will either be elected or he won't. So it's not clear what to make of this 30%, what that refers to. And so facing a probability, people are often motivated to simplify their decision making in various ways. One way is to round the probability because we don't know what to do with it. And so looking, for instance, at the 2016 sort of top level forecast presentation from 538, they really relied on win probabilities. And so I think, it's very easy to think that someone who came to this page might see, 71.4% for Hillary Clinton, not know what to do with that other than to perhaps round up, because we know that number's fairly far above 50%, and similarly round down for Trump. And so given probabilities, we might not actually incorporate the uncertainty into our decisions because we're trying to sort of figure out what to do with it. And one trick that can help, based on research going back to cognitive psychology in the 90s, is to take a probability, something like 30%, and frame it instead as a frequency. So rather than 30%, saying 3 out of 10 times Trump might win the election, for instance. And one of the reasons, or first I should say, the research in cognitive psychology originally showed that when you do this simple framing trick, people can do better on these kind of classic Bayesian reasoning tasks. So tasks that involve reasoning about conditional probabilities that are often hard for people. And so I think one of the reasons we might speculate that a frequency framing helps people do better when reasoning about uncertainty is that if you think about sort of how we experience uncertainty in our everyday life, we're thinking about sort of the probability of some event or how uncertain that is. It's often easy to think about it in terms of frequencies. So say I want to estimate, my probability of missing the bus if I get to the bus stop at the same time every day. I might intuitively think, well, yeah, about 4 out of 5 times or a week I catch the bus and 1 out of 5 times I miss it. And so frequency is kind of this natural sort of way of thinking about uncertainty. And interestingly, just this year, we see some changes in how the election forecasts are being presented, and in particular, use of a frequency framing, where we didn't really see this in the 2016 cycle. So both The Economist and 538, Economist on the top, 538 on the bottom here, are using this frequency framing. So 538 even shows a visualization. So here we're seeing 100 hypothetical outcomes, 100 hypothetical elections between Biden and Trump. And that's used to express, this 30 and 100, or this 30% probability as 30 and 100 Trump wins. And this ball swarm plot was actually one of the sort of innovative parts of this year's election forecast kind of presentation that 538 really talked about a lot when they talked about their process. And so, so this kind of framing trick could be useful. If you're a skeptic, of course, you might say, well, is this really so different from expressing a probability? How could it really change things? And in the case of, the visualization, like this ball swarm, how different is this than if we hadn't used this frequency framing? That's the kind of thing that my research, along with some collaborators, has been looking at over the past year. So, we want to know, how much does it help someone incorporate uncertainty into their judgments or their decisions? When we use, say, a frequency framing visualization, how do we design frequency framing visualizations that work? And so we have to grapple with some other questions, like how do we evaluate if an uncertainty visualization works at all? It's not always as sort of obvious as you might think. So one problem when we're trying to know, how well does a visualization technique for uncertainty work is that often it's hard to put our finger on sort of what the right outcome or decision should be from an uncertainty visualization. So if somebody's looking at an election forecast like 538's, what should they ideally do with this 30% chance of Trump winning? That can be hard to define, making these experiments on sort of figuring out the most effective chart difficult. There's also this problem where often, the way we study visualizations and which visualization is better depends on asking people to read the data. So, extract some probability, make an estimate. But one thing we know from a lot of research in people's use of uncertainty is that often there's no guarantee people will use the uncertainty information just because they can read it. Often we want to suppress uncertainty, so even if I ask you to read the chart, you might do it correctly, but then not actually make a decision any differently. And finally, what's even worse is that people are often comfortable with visualizations that don't show them uncertainty very well. And that's because we do ignore it or we suppress it. And so by suppressing it, we make our decisions easier. And sometimes, the visualizations that make it easier to ignore are actually liked more by people, even though they're not good for decisions. So these are all sort of challenges that we have to grapple with when we're asking decisions like, how effective is a frequency framing visualization like the 538's really in terms of helping people. But in our lab, we've done some research looking at sort of different ways of expressing uncertainty, including frequency framing. So here on the right, I'm showing what we call a quantile dot plot, where we're taking a probability distribution, in this case, showing uncertainty in predicted bus arrival times. So imagine I have a bus or a transit app that gives me predictions of bus arrival time. I could think of that as a distribution. This quantile dot plot is taking that distribution and expressing it in terms of dots representing, different possible bus arrival times, similar to the ball swarm that we saw in 538 selection. In studies, we've tested these a bunch against a number of other sort of more common representations, like a density plot, different types of intervals or error bars that we could use, even text expressions of uncertainty. These are all ways that we see uncertainty being communicated. And so in trying to answer these questions about how effective are these approaches, we often will use multiple methods. So because it's challenging to say with a single sort of method whether an uncertainty visualization is effective, we'll do things like first ask people to do probability estimates. So in this case, we did a big study with a bunch of bus riders and we asked them, what's your chance of missing the bus if you get to the bus stop at some certain amount of time or in some certain amount of time. But we also want to connect that again to decision making, because there's no guarantee that if you can read it, you can also incorporate it in a decision. So we also do studies that look at incentivized decision making. So in this particular case with these quantile dot plots, we did as well a study where we're having subjects basically make an incentivized decision about when to leave for the bus, where they get penalized if they wait at the bus stop too long, but they get a reward if they actually catch the bus. And so there's various sort of approaches that we can combine in order to get a sense of how well these things work. And what we've seen in this kind of research with these frequency framing visualizations, similar to the ball swarm that 538 used, is that one, they help people make more consistent probability estimates, so people can actually judge the probabilities better. And secondly, they lead to better decisions. And so, what we found is that when you show someone something like a density plot here in the middle, there's more error in any individual's judgment. It's almost as though sort of they're either not sure of what they're seeing, and so they're not sure how to interpret it, or making these sort of area judgments to estimate how much probability you have of missing the bus, et cetera, is difficult. It's error prone. For the decisions, we see things like, people can use or learn how to use things like intervals, but they're pretty bad when they start out and they don't improve all that much. So we can learn a lot about sort of effective visualizations through these studies. Okay, so we can use frequency framing. That's a good approach to communicating forecasts. But there's a few other questions I think we should talk about when it comes to visually communicating forecasts. And one of those is actually, again, not a visualization question. So for election forecasts, we often see one of two things visualized. So we either see vote share of some type, which gives us either the popular vote margin or the electoral college vote, the prediction of that proportion that goes to one candidate versus the other. On the other hand, we also see win probability, where we're seeing basically a translation of this vote share into a probability of winning. These have both their own pros and cons. So vote share is easier to understand often. Often we'll see the popular vote rather than electoral votes, and popular vote is what we create when we vote ourselves. So there's kind of a direct interpretation. But the problem with vote share is that it's a little bit removed from what we care about. What we want to know really is kind of what is the probability that our candidate wins. On the other hand, we can show people win probability, which answers that question, but it's more likely to be misunderstood. And one of the reasons is people don't grasp probability well, like we've talked about, they round up. Another reason, as you can see from these two charts, is that when we're mapping something like a vote margin to a probability, there's sort of an exaggeration of the difference. And a lot of people, not surprisingly, don't understand how this works. So you can have a big difference in probability from a relatively small vote margin. And so this is something that researchers have speculated may have led to potentially less voter turnout in the 2016 election, because a lot of the forecasts, the creators of the forecast were leading with probabilities of winning and not really emphasizing the vote share. But this is just a single study that's looked at this. There's still a lot to be determined, but as we can see, at least from looking at the graphics, there is a difference here that we should be aware of. Excuse me. So it matters what we visualize and how we visualize it. I think one intriguing possibility that I want to talk about for a few more minutes is to find a way to visualize something like vote share, but also get across something like probability of winning in the same visualization. That would give us kind of the best of both worlds. And so let's imagine we have data on vote share. Essentially, if I go back to this visualization, whenever we have something like this, we have an estimate and an interval for both Biden and Trump. We're basically talking about comparing probability distributions. We're trying to compare the estimates with uncertainty from these two candidates. And so you could imagine, I've just retranslated this into a bar chart with error bars. So two distributions. Often what we want to do is look at something like vote share or some other measurement, but answer questions or intuitively arrive at an estimate of sort of how reliable is this difference? What's the probability that blue, say Biden here, is going to win the election? And so if we just show probability, people can not realize how close the vote share can be, et cetera. But if we show visualizations like this that give us both distribution at once, what we find is that people will often use heuristics. So I don't know how to answer this question using the graphic I'm given. And so what I'll do is look at how big the difference is between the two averages. And so given a visualization like this, I might say, this is a highly reliable difference. Anything else with a big difference is highly reliable, whereas anything with a small difference is not very reliable. So we call these heuristics. They're kind of like mental shortcuts people use. The problem is that sometimes they fail. So when we have a small but reliable difference or a large but unreliable difference, we shouldn't make this kind of estimate. And one of the problems with even things like quantile dot plots or ball swarms is that we're seeing two distributions at once. And so we can always look to sort of estimate the average and ignore the uncertainty information to some degree. So one way we can get around this is actually showing people outcomes, but now showing them outcomes over time. So these are hypothetical outcomes. We call these hypothetical outcome plots. And one second. What you'll notice is that now you can intuitively estimate something like what's the probability blue will win, but at the same time, you're getting the underlying measurement data, say vote share in this case. And so this is a way of sort of showing uncertainty that's a lot harder to ignore. I can't just focus on the average because I have to actually intuitively estimate the average using the uncertainty. So we don't see these in the election forecasts this year, but we've seen them quite a bit in the past, actually used among sort of the top journalism outlets like 538. And one of the reasons I think these animated representations of uncertainty can be useful is that often you have a complex visualization or you have some measure that's hard to simply add an uncertainty encoding to. So you can't just put an error bar on something. So for instance, 538 has used these to show uncertainty in a ranking. So in this case, who's likely to be in the GOP debates was the question. These different outcomes, and it gives you a sense of uncertainty in a rank. Another reason these are appropriate, in particular for election forecast data, is that often when we have a forecasting model, it's a complex model, and it might be capturing a lot of dependencies or correlations between things like different states that it's making predictions for. Excuse me. So for the Economist forecast this year, one of the things that they highlight through an interactive visualization is that a lot of states' voting behavior is correlated. So depending on what Idaho votes, we can expect a similar vote in some of these neighboring states, and Idaho tends to not be very related to how California votes. So in a complex model, these dependencies often matter a lot. And so it's very difficult to capture them. Sorry. It's very difficult to capture them in a single static graphic. This is a problem we face all the time in visualizations. On the other hand, if we can animate outcomes, we can naturally show things like correlation. So these are predicted voting results from the 2008 election, but sort of gives you the idea that states can move together, and we can show this in a visualization without having to do something like this interactive thing where you have to hover over each state to see each state's information. Okay, finally, animating uncertainty makes it a lot more visceral. It's harder to ignore. And you might have noticed that just as I've shown these visualizations. That can be a little bit overwhelming given our innate tendencies to try to ignore uncertainty. To see a visualization that forces us to contend with it is difficult. And so you might recall as an example of this, the New York Times Needle from the 2016 election. This was unrolled on election night, and it's combining a static display of uncertainty. So you can see kind of in the background here, you have the static, shading-based visualization of uncertainty in vote margin. But then it's also animating outcomes, and new data was coming in during election night, and so the needle was moving with some randomized jitter within a confidence interval, but also new data was coming in, which was updating. So people really rallied against this visualization. I think personally, one of the issues was not that this was not an effective visualization. So it showed uncertainty and it made it very visceral, and it was very hard for people to ignore it. I think the real problem was that this was introduced not until election night. And so if we'd seen something like this leading up to the election, I think perhaps we would have been more used to uncertainty and less surprised then when the visualization showed us something that we hadn't expected to see. So it's an example, though, of how, making uncertainty visceral and hard to ignore can lead to some reader discomfort. Maybe visualization should induce uncomfortableness proportional to uncertainty. That's kind of my view. But at the same time, we don't want to alienate readers. And so, the note to forecasters would be, if you're going to do something like this, take into account, how you might give the reader some control back, make it interactive, et cetera, so they can pause it, et cetera. Okay, finally, I want to just close by commenting briefly on forms of uncertainty that I haven't discussed, but which are really critical to communicating forecasts. And these are the uncertainties stemming from our inability, as model developers to quantify how good our model is in various ways. So all models make assumptions. As a famous, statistician said, all models are wrong, but some are useful. A model is only as good as its assumptions. And so, this doesn't mean that forecasts can't help us make better decisions, but we have to be aware of this dependency on assumptions, and we have to be aware that there's uncertainty that we can't always see visually because it's not quantifiable. And so, how forecasters should express this is really an open question. We don't know a lot about how to express uncertainty well in text. When it comes to election models like 538s or The Economist, we want to express uncertainty related to things like how much should we trust the poll data? How much should we trust our assumptions about, uncertainty from COVID? It's not clear how to do that. Something that 538 did this year, which I think is really interesting and innovative, is introduce this Spivey Fox cartoon character who's basically, you're going to see him around all of the forecast graphics that they're showing, and he's giving you advice often about how to keep in mind the uncertainty that's lurking, sort of, that maybe is based on the things that we can't quantify. So sometimes he gives advice on how to read the chart, but often it's emphasizing things like, upset wins are still possible, even though the trend appears to be in the opposite direction. So I think this is, a really nice attempt to communicate some of this other uncertainty. We still maybe have a long way to go. What I'd really like to see is forecasters really talking about model assumptions more in a sort of accessible way. I think as readers, what we need is to develop literacy around these things. But steps like 5e Fox, steps like frequency framing of uncertainty are really showing us progress, I think. And so as readers, we need to keep expecting to see this kind of thing and trying to get better at reading it ourselves. So I'm going to conclude there. It's been great to share these thoughts with you. You can find me online if you're interested in more. Thank you.
Well, thank you, Dr. Holman, for your time and your research. That wraps up tonight's program, so thank you for watching and continuing to learn with us. Your support is invaluable. We hope you'll join us next week as we take a closer look at how we exercise our choice through voting. We'll see you at the next After Dark Online.